As I discussed in the last video, energy can transfer into or out of a system. If energy is coming in, of course, the energy in your system is going to go up. If I transfer 100 joules to you into your system, the total energy in your system is going to go up by 100 joules. If your system has 1,000 joules of energy and you somehow transfer out 200 joules, then of course the energy in your system is going to go down by that amount. So 1,000 minus 200 joules is 800 joules. That's the basic idea. One of the key rules of energy is that energy can leave or come into a system by energy transfer. And I talked briefly because I like to talk about this is how do I get energy into a child? You feed them a sandwich. How do I put energy into a car? Typically, you're going to put in some gasoline. How do I get energy into a plant? You're going to put light energy. You're going to shine light or maybe just allow the sun to shine light on it. Let's talk about work and this category of energy called mechanical energy. And let's go through some examples first before we even just try to talk about what mechanical energy is. Here's our first example. Let's take a look at a ball that is not moving, and then you want it to start moving. You want it to be moving. Okay. Well, that means it's going to go from having no energy, and then I'm just going to make up a number here. Typically, okay, let's try something other than 100. There's 80 joules. So here, at this moment in time, you're going to say, oh my gosh, the kinetic energy, I'm just going to write EK there because I don't want to erase it, is 0. And then later on, these are the same thing, just kinetic energy. And now it's got 80 joules. You know that there must have been an energy transfer taking place because we start out with, hey, there's no energy in our system. Just assume that's a true scenario here, true. And then it ends up with 80 joules. This does not involve where you had one form of energy transforming into another. This is just hey, my system has no energy, and then it ended up with 80 joules of energy. How did that energy get in there? If you look carefully at this ball, you're going to see there's no mouth. Nope, there's no mouth. There's no place to put gasoline. Nope. There's no place to put a battery. There's no place to plug it in. So how do you transfer energy into something like a ball that isn't moving and then now, suddenly it has 80 joules? Well, basically, you have to do work on it. You have to have a force acting through a distance will transfer energy. So in this case, something or somebody did 80 joules of work in order to give this ball 80 joules of kinetic energy. Okay, let's look at another scenario. Suppose I've got a box, and the mass doesn't really matter, but it's just 5 kilograms, and you come across it here. It's on the floor, and we're going to say that right now it has no energy. Okay, I know you could burn the box, but I don't want to focus on that. Just say right now it has no energy. All right, and then either because you did it or you just come later and you see that, oh my gosh, this thing has now elevated. Basically, we've got a place where there's gravity pulling this thing down, and somebody pushed this box up to this shelf. And you don't really know how to do it yet, perhaps, but we're just going to say, oh, it now has 200 joules of gravitational potential energy. And you know from our rules about energy that energy can't be created. And so if you went from a situation where your system had no energy and now it has 200 joules of energy, in this case in the form of gravitational potential energy, there was an energy transfer. But you look carefully and there's no mouth on this box to insert a sandwich. There's no gas tank. There's no battery pack place to put batteries. There's no place to plug it in. So how did you get energy into this box? And the idea is, this is another example of, there's only one way you can put work into something like a box, and that is you or somebody else had to do 200 joules of work. So as somebody raised this thing up against gravity, that takes a certain amount of force, and it did that through a certain distance. And when you are exerting a force through a distance, that's called work. And so work, let's go back to this example here. It went from 0 joules to 80 joules, and that is kinetic energy. And again, so somebody had to transfer in 80 joules, and the only way you're going to do that with something like a ball to get it moving is by doing work, by exerting a force through a distance. I'm trying to pause it. Okay, in this last example, let's look at a spring. Just a basic mechanical spring, and you come across it and you see, oh, it is in its unstretched state, its natural shape. All right, so you're going to say, and you got to trust me here, is, oh gosh, there's no energy in this spring system thing. And then you come across it later and you see that it has been squished. And one of the things we're going to learn about spring energy, I think you can get this anyway, is, okay, if you squish a spring, there's now energy in that spring. And let's just make up a number here and say that it has 300 joules of elastic potential energy or spring energy. And you know from conservation of energy that if you go from 0 joules to 300 joules, that's an energy transfer, and so that energy had to come from somewhere. And so where did it come from? And maybe you're getting tired of this, but you can't shine a light on a spring. Well, you can to make it a little bit warm, but it's not like a plant, it's not a child, it's not a car, there's no battery case. So how do you put energy in something mechanical like a spring? And the idea is there's only one way, and that is you have to exert a force, and you have to exert that force through a distance. And so what you end up doing is you do work on this spring. And if it ended up with 300 joules of energy when it started out with none, then you had to do 300 joules of work. So let's just summarize this. Okay, so these three forms of energy, kinetic energy, gravitational potential energy, and elastic potential energy, are all lumped together and given the general name of mechanical energy. And I don't know exactly why somebody started using the term mechanical energy, but I do know why they were grouped together. Because work is the only way to transfer into a system these forms of energy. Now, I'm already thinking of an exception here, but this is in general. Okay, so we lump these three forms of energy together: mechanical energy, kinetic, gravitational potential energy, and spring energy. And the way you transfer energy into or out of a mechanical system involving these forms of energy is by doing work. So if you want to give your system energy in the form of kinetic energy or gravitational potential energy or spring energy, is you or somebody you know is going to have to do work. And that would be work coming in. And if your system has any of these forms of energy, then that means it can also do work on something else, and that could be work out. So this is the idea. This is what this means, is work is energy transfer. That's what these symbols are saying. Work is energy transfer, sometimes into a system. If you do work on a system, you are literally taking energy from you and you're putting it into this thing. When you squish a spring, You're taking some of that chemical energy stored in the muscles of your body and you are transferring it to the spring. If you do 100 joules of work on a spring, compressing it, you give up 100 joules, it gets in 100 joules. It really is an accounting game. Okay, so the next video is going to kind of, okay, well, how do we quantify this work? This is what work does, but how do I quantify the amount of work being done? Okay, bye.